Video we are going to study dimensions and dimensional analysis. The dimension of a physical quantity are the power to which the concerned fundamental unit must be raised in order to obtain the unit of the given physical quantity. Here we will take an example to understand it. Example is dimensional formula of velocity is equal to displacement upon time. Here displacement is the unit. Here displacement has the unit meter and time has the unit second. Here we have to find the dimensional formula by using L, M and T. Here L means the length, which is measured in meters. M is the mass, which is measured in kilogram, and T is the time, which is measured in seconds. Here in this formula M and S is present and S is in the denominator, so T raised to minus 1, L raised to 1 and M. Here no mass is given, therefore M raised to 0. Next, in this way we can find the dimensional formula of any of the quantities. First, now second example is of force. The unit of force is Newton, and therefore 1 Newton is equal to kg meter upon second square. Therefore L raised to 1, M raised to 1 and here it should be T raised to minus 2. T raised to minus 2 because here S square is taken. So next is work done. So the unit of work done is joule. Joule is equal to Newton meter. So here is the 1 Newton is equal to kg into M upon S square into M. Therefore its dimensional formula will be meter square kg meter into meter upon second square. Therefore L raised to 2, M raised to 1 and T raised to minus 2. Next, pressure. The unit of pressure is Pascal and therefore kg M raised to minus 1, S raised to minus 1. So its dimensional formula will be L raised to minus 1, M raised to 1 and T raised to minus 2. Next, power. The unit of power is joule per second and it's kg M raised to 2, S raised to minus 3. Therefore the dimensional formula will be L raised to 2, M raised to 1 and T raised to minus 3. Sixth, acceleration, and its unit is meter per second. Therefore L raised to 1, M raised to 0 and T raised to minus 1. We are going to study the uses of dimensional analysis. The first use is to check the correctness of any physical equation. So it is used to check that any physical equation is correct or not. First, for example, Newton's first equation. The first equation of Newton is V is equal to U plus AT. Dimensions on LHS means the dimensions of V. These are the dimensions of V. L raised to 1, M raised to 0 and T raised to minus 1. Dimensions on RHS. So what are the dimensions on RHS? Means U plus AT. So U, the dimension of U is L raised to 1, M raised to 0 and T raised to minus 1 plus AT. It means AT means for A is L raised to 1, M raised to 0 and T raised to minus 2, and for T is L raised to 0, M raised to 0 and T raised to 1. So by using this identity, M upon A raised to M, A into A raised to N is equal to A raised to M plus N. So by using this identity we will get L raised to 1 plus 0, M raised to 0 and T raised to minus 2 plus 1. So the final answer we will get L raised to 1, M raised to 0, T raised to minus 1 plus L raised to 1, M raised to 0 and T raised to minus 1. So we will get minus 1. So we can't add this 2 because this is the dimension formula for velocity and this is the dimensional formula obtained from the product of acceleration into time. So we can't add them when we compare LHS, means the dimension formula of LHS with the dimension formula of RHS, we can see that the both are equal. So we can conclude that LHS is equal to RHS. In this way, we can check the correctness of the physical quantity of any physical quantity. Second, its second use is to establish the relationship between physical quantities. Means it is used to establish the relationship between two physical quantities. Like for example, F is directly proportional to m raised to x. If F is also directly proportional to a raised to y. So from this two we can conclude that F is directly proportional to m raised to x into a raised to y. So when we remove this proportionality sign, we have to put a constant. So k is the constant. F is equal to k mx into a y. So here we have to consider that, assume that k is a dimensionless quantity. So first we have to find the dimensions of f. So the dimension of f is this. Then as k is a dimensionless property, we have to keep it as it is. Then the dimension of mass, then we have to find the dimension of mass, as the unit of mass is kg. So only m raised to 1, and this to be L raised to 0 and T raised to 0, and we have to close it in a bracket and then raised to x, as there as here m raised to x is taken, and then we have to multiply it with the dimensions of acceleration, and then we have to close the bracket, and then we have to write raised to y. So by using this identity m bracket and then n is equal to a m into n. So here we will get L raised to 1 m raised to 1 t raised to minus 2 is equal to k L raised to 0 m raised to x t raised to 0 into L raised to y m raised to 0 and t raised to minus 2y. So by using this identity, we will get L raised to 1 m raised to 1 t raised to minus 2 into is equal to k then bracket L raised to y m raised to x t raised to minus 2y. Then we have to compare it on both sides. So here the value of y is equal to 1 and the value of x is also 1. So from by comparing, we will get x is equal to 1 and y is equal to 1. Then we have to substitute the value of x and y in equation 1, and this is the equation 1. Then we will get, from this we will get f is equal to kma, and the value of k we have to find is determined experimentally. So ultimately the formula for force is equal to ma. Its third use is to find the conservation factor between the unit of same physical quantities in two different system of unit. For example, see, distance, its SI unit is meter and CGS unit is centimeter. We know that 1 meter is equal to 100 centimeter. Then mass, the SI unit of mass is kilogram and the CGS unit of mass is gram. We also know that 1 kilogram is equal to 1000 gram. But do we know that the work has SI unit joule and it has CGS unit erg? Do we know that how many joule? 1 joule is equal to how many erg? So let's find it. 1 joule is equal to x erg. So we know that 1 joule is equal to 1 kilogram meter upon second square into meter. That is equal to kilogram meter square second minus square. So the dimension formula of work is this: L raised to 2, m raised to 1 and t raised to minus 2. Then t raised to minus 2. Then we have to substitute this formula into equation equation 1. We have to substitute this formula into equation 1. As joule and erg both are the unit of work, they both will have the same dimension formula. Therefore L1 raised to 2, m1 raised to 1, t1 raised to minus 2 is equal to x, L2 raised to 2, m2 raised to 1, T2 raised to minus 2. Then we have to take this equation into the left hand side, and then we will get this x is equal to L1 raised to 2 m1 raised to 1 T1 raised to minus 2 upon L2 raised to 2 m2 raised to 1 T2 raised to minus 2. Then by using this identity we have to we will get, by using this identity we will get this equation L1 upon L2 L1 upon L2 raised to 2 m1 upon m2 raised to 1 T1 upon T2 raised to minus 2. Then L1 is the SI unit, so it will become meter. L2 is the CJS unit, so it will become centimeter. M1 SI unit, so it will become kilogram, and M2 is the CJS unit, so it will become gram. T1 is the SI unit, so it will become second, and T2 is the CJS unit, so it will also become second. Then 1 meter is equal to 100 seconds, 1 meter is equal to 100 centimeter, and 1 kilogram is equal to 1000 gram. So this therefore this centimeter and this centimeter gets cancelled, and then this gram and this gram gets cancelled, and second gets cancelled. Then we will get x is equal to 100 into 1000 into 1 raised to minus 2. Anything raised to 1 is 1. Therefore our final answer will be x is equal to 10 raised to 7. Therefore joule is equal to 10 raised to 7 erg. In this way we can find the conversion factor between two units of some physical quantities in two different systems of unit by using dimension formula.